Welcome back to Bot Thoughts by AmTalkSoft. I'm Alex. A friend of mine shipped a prompt change 2 months ago that her team's LLM-Judge said was 31% better. The graphs were green. CI gates passed. Pairwise win rate, 78%. They deployed on a Tuesday morning. By Thursday, support CSAT had dropped 11 points and 3 account managers were on the phone with her asking what had changed. The new summaries were longer, more flowery, and consistently buried the customer issue under 3 sentences of preamble. The judge was perfectly calibrated to the wrong thing. With me to talk about why production eval pipelines lie and how to build one that doesn't is Sam. Sam, welcome back.
Thanks, Alex. I love this story because it's the most common LLM eval failure mode in production right now, and almost nobody is honest about it. The judge is not lying on purpose. It's showing you exactly what you asked it to score. The problem is what you asked it to score is not what your users actually want. Most teams set up an LLM-Judge in an afternoon, hook it into CI, run it for 2 weeks, see green dashboards, and assume the eval is solved. Then they ship a regression that the judge said was an improvement, and the judge keeps saying it's an improvement even after the CSAT drops. We've watched this happen at 4 different companies in the last 6 months. The fix is not a better judge. The fix is structural, and almost nobody is teaching it.
Before we tear it apart, give me the case for using an LLM-Judge at all. Some listeners are going to say, just use humans. What's the economic argument?
The economics are real, and they're why every team eventually adopts judging. Human evaluation is the gold standard, and human evaluation is also slow, expensive, and high variance. A team running 200 prompt changes per quarter cannot afford to label 200 sets of 200 outputs by hand. At May 2026 pricing, GPT-4o scoring runs at roughly half a cent per judgment. 1,000 example eval costs about $5 and finishes in 4 minutes if you parallelize. The same eval done by humans at $1 per labeling costs $1,000 and runs 3 days. That's a 200x cost gap, and it's why judge-based pipelines are everywhere. The Zhang et al. 2023 paper, the MT-Bench paper, showed GPT-4 agreement with human raters on pairwise judgments hits 85% on conversational tasks, which is roughly interhuman agreement. The judge is good enough for many production gates. The mistake is using it without calibration.
Right, so it's not the judge that's broken, it's the loop around the judge. Walk me through the biases. I keep hearing about position bias and length bias. How many are there really, and how big are they?
The literature has converged on 5 known biases that show up reliably across model families. Position bias. When you give the judge 2 responses, A and B, it systematically prefers one position over the other, with a documented bias size of 4 to 18% depending on model and task. Length bias. Judges prefer longer responses, full stop, and the bias holds across GPT-4, Claude, Gemini, and most open-weight judges as of this year. Self-preference. Judges prefer responses from their own model family. GPT-4 prefers GPT-4 outputs over Claude outputs, with bias around 2 to 7%, and that's enough to swing a model selection decision. Sycophancy. If your judging prompt mentions which response is the new one or the production candidate, the judge tilts toward the labeled candidate. Even subtle hints move the score. And refusal bias. When responses include any safety-adjacent content, judges over-reward the safer answer, which is fine when safety is the eval target and a problem when it's not. Each of those 5 has a documented mitigation. Skipping any one of them is the most common reason production pipelines lie.
Position bias is the one I see most often. Give me the fix. Is it really just swap the order and run twice?
Yes, and I want to be very specific because this is where teams cut corners. You run pairwise judgments twice with positions swapped, and you only count a winner when both runs agree. If run 1 says A wins and run 2 says B wins after the swap, that's a tie. Tied or split runs become ties in your aggregate score. This doubles your eval cost and is non-negotiable. The reason teams skip it is the cost doubles. The reason they regret skipping it is the bias is large enough to flip a deploy decision. We measured an 18% position bias on a customer support summarization task using Claude Haiku as judge last quarter. That's enough to ship a regression that pairwise scoring without position swap would have called a win. The cost of running twice is real. The cost of shipping a regression is much higher.
Okay, length bias. My friend's incident was basically length bias plus a rubric that valued completeness. How do you fix that one without telling the model some hand-wavy thing like, quote, prefer concise answers, end quote?
Hand-wavy doesn't work. The fix is rubric grounding with explicit length penalties. Your judge prompt should literally say, longer responses are not better, and then it should give the judge a numerical penalty rule. Something like, if the response is more than 30% longer than necessary to answer the question, deduct 1 point. The numerical anchor matters because LLM judges follow rubric scaffolding much more reliably than they follow generic instructions. We've A/B tested this. A judge prompt with the words, quote, prefer concise answers, end quote, has roughly the same length bias as a judge prompt with no instruction at all. A judge prompt with an explicit deduction rule cuts length bias by about 60% on the same eval set. The instruction has to be measurable and tied to a number. Soft language gets ignored.
Self-preference is the one that makes me nervous because it's the hardest to notice. If I'm using GPT-4 as the judge to compare GPT-4 versus Claude, am I just choosing my own team?
Effectively, yes, by 2 to 7%. The fix is ensembling judges across families. Run the same eval through GPT-4o, Claude Sonnet, and an open-weight judge like Llama 470B judge or QN 2.572B only count a verdict when at least 2 of 3 agree. Disagreements become ties or get flagged for human review. The cost is roughly 3x the benefit is your model selection decisions stop being self-fulfilling. We caught a real one in March. Internal team picked Claude over GPT-4 on a code generation task using Claude as judge. We reran the eval with a 3-judge ensemble. It came out a tie. The actual production data, when we eventually shipped both behind a feature flag, also came out a tie. The single-judge eval had been telling us a story we wanted to hear.
Sycophancy. This is the one where you tell the judge, quote, this is our new prompt, end quote, and the judge says it's better. How subtle do the hints get?
Subtler than people think. Even the words new, improved, candidate, or production in the prompt nudge the score. The fix is blind grading. Swap response provenance to opaque labels. Never response old versus response new. Never candidate A versus production baseline. Always response X and response Y, randomized per judgment, with the mapping stored in a sealed log that the judge cannot see. The randomization matters. We had a team that used static labels, response X always being the new one and response Y always being the baseline, and the judge learned the pattern across many calls. Or rather, the prompt template did by always biasing the same direction. Per judgment randomization kills that. And the rule we enforce now, if your eval pipeline source code contains any of the words new, old, baseline, candidate, production, or improved as a label string, the CI check fails. It's that strict.
All right, that's the bias mitigation. But you keep saying that's not enough on its own. You said the structural fix is something called the 3-layer eval stack. Walk me through it.
Layer 1, unit eval, programmatic checks against ground truth wherever ground truth exists. JSON schema validation, regex matches for required entities, exact match scoring, citation presence checks. Fast, free, runs in milliseconds, catches the regressions that have nothing to do with subjective quality. If a code gen prompt is supposed to return valid Python, Layer 1 runs the parser. Layer 2, the LLM-Judge. The pairwise or rubric-based ensemble we've been talking about, with all 5 bias mitigations applied. This is the workhorse. Scales to thousands of examples, runs in minutes, approximates human judgment well enough for most production gates. And Layer 3, human rater calibration. A small set, 50 to 200 examples, labeled by humans, run weekly. The calibration set's job is not to evaluate the candidate. Its job is to evaluate the judge. If the judge's verdict on the calibration set has drifted away from the human verdict since last week, the judge is wrong, and last week's Layer 2 numbers are suspect.
I want to push back on Layer 3. 50 to 200 examples weekly is real human cost. A team has to actually staff that. How do you justify it?
You justify it with the cost of being wrong. The team I described in the intro, the 11 CSAT point regression, ran for 10 days because there was no human anchor. The financial impact was conservatively estimated at $400,000 in churn-adjusted revenue. The cost of running a 100-example human calibration set weekly at $1 per labeling is $100 a week. Over a quarter, $1,300. Against $400,000 of avoidable damage. The math is not close. And the calibration set is shared across all the prompts the platform team owns, so it amortizes across every CI run. We use a pool of internal raters, blind to which response came from which prompt version, and they label maybe 20 examples a day each. It's not heavy. It's just non-zero, which is what teams object to.
When the layers disagree, what do you actually do? Disagreement seems like the most useful signal, but also the hardest to act on.
Disagreement is the signal. The output of the three-layer stack is not three numbers. It is one verdict with a confidence flag. If all three layers agree, ship. If layer 1 fails on schema or citation, do not ship. This is a hard regression. If layer 2 and layer 3 agree but layer 1 fails, you have a quality improvement that broke the contract, fix the contract, or fix the prompt. If layer 2 and layer 3 disagree on the calibration set this week, hold the deploy and investigate the judge. The disagreement triggers a forensic. We had one in February where layer 2 said a prompt was 15% better, and layer 3 said it was 3% worse on the calibration set. The forensic found the judge prompt had drifted. A colleague had added an instruction 6 weeks earlier that was now interacting with the new prompt style. We fixed the judge prompt, reran the eval, and the disagreement collapsed. The disagreement caught the judge before the judge caught the users.
There's a third failure mode you mentioned earlier, eval set bias. Even with calibration, the eval set itself doesn't represent production traffic. How do you handle that?
Eval set bias is the silent killer because the judge can be perfectly calibrated on the eval set while still missing the regression that hits real users. The fix is sampling from production traffic into the eval set continuously. Every week, we pull a stratified sample of 200 real production requests, anonymize them, and add them to the eval set. We retire the oldest 200. The eval set is alive. It tracks the production input distribution. We also run a coverage metric. What percentage of new production requests by topic cluster are represented in the current eval set? If a new feature has launched and the eval set has 0 examples from that feature, your eval is blind to it, and you flag the gap before deploying anything that touches that feature. The stratified sample plus coverage metric plus weekly rotation is the discipline that keeps the eval set honest. It is operationally heavy. It is also why our pipeline catches things that other teams' pipelines miss.
Quick tactical question. The rubric. Is there a template for this? Because I see teams just write a paragraph of, quote, score on accuracy and tone, end quote, and call it a rubric.
A paragraph isn't a rubric. A rubric is a numbered list of criteria, each with a score range, each with examples of what each score looks like. 4 to 7 criteria is the right count. More than that, and the judge starts averaging. Fewer and you miss dimensions. Each criterion needs a one-sentence definition, a scoring scale that's small, like 1 to 4, and at least 1 positive and 1 negative example. The judge follows the rubric structure 10 times more reliably when it's enumerated than when it's prose. We also include the rubric criteria as the response format the judge has to produce, not just the verdict. The judge has to output a per-criterion score plus a one-line justification per criterion plus the final verdict. That structure forces the judge to actually consider each criterion rather than just emitting a vibe-based answer. Cost goes up about 30%. Reliability goes up far more than that.
Let me try to summarize. 5 biases with 5 mitigations: position swap and average, length penalty in the rubric, ensemble across model families, blind grading with randomized opaque labels, separate safety from quality. Then 3 layers: programmatic unit eval, calibrated LLM-Judge ensemble, human rater calibration set weekly. Then continuous sampling from production traffic to keep the eval set honest. plus a rubric that's numbered, scaled, and exemplified. Did I miss anything?
One thing, the judge prompt itself is a prompt, and it deserves the same versioning and review process as your production prompts. Store it in Git, code review it, test it on a frozen calibration set when it changes. We had a colleague edit our judge prompt to add a new criterion, and the change landed on a Friday afternoon without review. Monday's eval was 20% more lenient than Friday's. We rolled back the judge change before any production deploy went out. The judge prompt is critical infrastructure. Treat it that way.
That's the playbook. We've got a deep dive blog on this exact topic at amticsoft.com, blog 178, with the code patterns and the calibration loop architecture. If you've shipped an LLM-Judge into production and you've never built the human rater anchor, that's the missing piece. If this episode helped you avoid an 11-point CSAT regression, support the show at buymecoffee.com/amticsoft. Next week, we're talking about embedding model migrations, how to swap your embedding model on a 50 million document R/G corpus without taking the search down. Sam, thanks. See you next time.